Well, I explained this a little bit to your class last week. I wasn't really happy with my explanation of simplifying roots and radicals. So I'm going to look at this again, and you have this sheet, which you always get to use, okay? Now, on the first side of the sheet, you see these same numbers that have been up on the board, 1, 4, 9, 16. Those are square roots, okay? All these are your perfect squares because there is a number time used as a factor twice, repeated factor twice, that gives you that product right there. Okay, now there's also a perfect cubes. That means, and these are my perfect cubes, 1, 8, 27, 64, 125, 216, and then it goes down the line. You can definitely see it. Okay, now the reason 125 is a perfect cube is because there exists an integer that if I use that same integer as a factor 3 times, it gives me 125, and it's 5. So the cubed root of 125 is 5. Okay, there's an infinite number of roots, but we only go really squares, cubes, fours, fifths, and sixths. We don't really use anything else. So, and here you can see we have fourth roots. If there's a little 4 there, that means what number used as a repeated factor 4 times gives you, let's say, 625. Okay, well, I can see off to the side here, 5 times 5 times 5 times 5 is 625. So if they ask you what the fourth root of 625 is, it's 5. And then you can see fifths, okay, and sixths. Okay, now when we do this assignment, we're actually I need to see 2 columns, and you're going to do the problem 2 ways. Now, some of the answers that you get are going to look really different, but some of them will look exactly the same. So the first way I want you to do it's really easy. You just do the root on your calculator. Now, if you don't see a number here, see some of these have numbers, it's automatically a 2. It's a square root, okay? Here, I'll use a pen so you guys can see it better. It's a 2. Okay, so we know how to square root. We've been doing that for a long time. Second, x to the second power, 9, and I get 3. Now, the other way we do it is we're going to look at our perfect squares on my list, and I see 9's on here, so I just write the number 3. So those look exactly the same. Now, 2 is an even root, so it could be repeated as a positive factor or a negative factor because you're multiplying it twice, an even number of times to get the 9. Basically, even means you'll have a plus negative. If that was an odd, I'd just put positive. Okay, now the next one, again, that's a 2 if we don't see it, so I square root 98, so I go second, x to the second, 98, and that's going to be 9.90. There's a 9 in your third digit place, so it goes from 89 to 90. You can put 9.9 if you want. Okay, now the second way is I use my list of perfect squares, so 98 falls in this range. I'm still on the same list, perfect squares. Okay. So I take 98 and I'd start at 81. And that's a decimal, so I can't use that. 98 divided by 64, decimal, 98 divided by 49. Boom. Okay. So I make 2 square roots. And I put 49 and 2. And 49 gets replaced with its equal, which is 7. And I keep the square root of 2. Now, if it's a square root, you can put a 2 there. You don't have to, because without a number, it automatically is a square root. Okay, so these are my 2 answers. They look very different, okay? But this was calculated. This is the exact. Okay, because when we do this standard after Christmas break, you're going to need to know how to do both ways. Okay, now you have a cube root. Now the first way I'm going to do it's with my calculator. You can do cube roots on your calculator. First off though, you have to do it different. If it's not a square root, it's a cubed root. It's asking what times what's 27. You go 3 because it's a cubed root, and then you go second, but you don't hit the x squared. You hit the button above it. Okay, so that tells your calculator this is a cubed root, and then 27. So I got 3. Oh yeah, by the way, go back up this one. We have a 2 there, so both these answers have plus negatives in front of them, positive or negative. Okay, now the second half we're using our sheet, but we're not going to be using the same list. This is a cubed root. So now I go to my perfect cubes, and I see 27 is actually on the list, and it's equal to 3. Okay. But I do not put plus negative in front of these because that's an odd root. Okay, so it can only be the positive factor used 3 times as a factor to get 27. Okay, the cubed root of 8. So again, let's use our calculator. Practice doing it on your calculator. 3, and then second, and then this key here. Not this one. That's 8, and I get 2. I think you'll understand why when you look at the list. So remember, you're not doing the perfect squares, you're not perfect cubes. 8's on the list, and it equals 2. Why? Because 2 times 2 times 2. 2 is the repeated factor 3 times. It gives you 8. Okay, only the positive though. Okay, now here, cube root of 54. So I go 3. And then second, remember this key here, the upside down V, 54. It's like when you do second, it's usually the opposite. So it's the opposite of an x. Like the opposite of x squared is square root. The opposite of any exponent would be the root. Okay. And that gives me 3.78. If you're off on your rounding by 100th, that's fine. Okay, now the next one I'll be trying to divide by the list on this one. Okay, so 54 ain't on the list, and that's why we got a decimal that we had to round off and terminate. So 54, I'd start in here. We try 54 divided by 27, and I get something right away. So I make the 2 roots. Now they're both cubed roots, so I put 3's in that groove. Okay, those aren't exponents. You put it in the groove kind of. And you get 27 and 2. You want to put them in that order because you're going to eliminate the first one because we know that has an equal of 3. Okay, so it's 3 cubed root of 2. Now, since it's a cubed root, we don't put the plus negative. But you need the little 3 there, definitely. Because if you don't put a 3, you're telling me it's a square root. It's not. Okay, so next one, easy money on the calculator. So 3 second, and this key here, 56. That's 3.83. And then now I go to my cubes list and see what I can divide into 56. So 56 divided by 27 is a loser. Okay, 8. 56 divided by 8 is 7. Okay. So I'd go to make my 2 roots, just like I normally do, and I put 8 and 7. Okay, we know this can be eliminated because that has an equal of 2. Okay, so 2 with a cubed root of 7. Remember to put the 3 in there so you know it's a cubed root. Okay, now this one's a little bit different. The first one, so you go 3, second, and then this key here, 15. And that tells me 2.47. And again, I'm not putting plus negatives because it's an odd. 3 is an odd root. Okay, now the second one, I go to cube and I try to divide 15 into these values here. It's not on the list, so I do 8. Okay, that does not work clearly. And I don't do 1. So if I can't get it to divide by anything, I just basically rewrite the problem. Okay? Because it means it can't be simplified using that method. Doing a 1 doesn't do any good. All it does is put a 1 outside, which is stupid. Okay. All right. Cube root of 256. So 3. Then I go second. And that same key, that tells your calculator you want a cube root. And that's going to be 6.35. And using the second method that you guys don't like, 256 that's a 216. So 256 divided by 216 is a loser. 125 loser. 256 divided by 64. Okay, I got that to work. So I make 2 cubed roots. And we have 64 and 4. So remember, the cubed root of 64, I lose that because that can be simplified into the integer 4. So I have 4 with a cubed root of 4. Okay, now the next one. Now you have a 4th root, so we go 4 second here, and that gives me 16. Okay, I got 2, nice solid number. Now it's an even, so that's a plus negative. I'm back to putting the plus negative. Now I can't be on my same list. Okay, I got to turn the page over because now I'm at 4s. It's a 4th root. And 16's on the list, so it's 2. Anytime you do your calculator, you get a nice round whole number, not a decimal. These are going to look identical. It's when you get a decimal that they look different. Okay, so cube 4th root of 81, so I go 4 second and then hit that key 81. I got 3. Now I go look up 81 on my list, same list, 4th, and that's on the list. It's equal to 3. Plus negative because it's a 4th. Okay, 80. So I go 4 second, and then the upside down V, 80, and I got 2.99. Again, a 4th makes it positive or negative because you can use a negative factor 4 times and it will equal the positive. Okay, then in my next thing, I go 80 was not on the list. That's why I got that decimal. So I'd start at 16. It's either 16 or I'm just going to write that down. 80 divided by 16. Okay, that worked. So I make 2 4th roots. And I put 16 and 5. Because 16 times 5 is 80, so I'm just breaking it into its 2 factors. So the 4th root of 16 is 2. It's not 4. It's not a square root. So you got 2 4th root of 5. You put the plus negative in front of it. So these answers look very different. And that's going to happen when that's a decimal. Okay, the 4th root of 100. So I go 4 second. This key here, 100. That's 3.16. Plus negative. This answer is going to look different because that was a decimal. So I start dividing 100 by the 4. So you got the biggest key on here is people don't know what lists are on. That tells you what you should be on. So 100 divided by 81 ain't going to work. 100 divided by 16. That does not work. Okay, and then we come to 1, which means I'll just write that down. And it's 4, so I just put a plus negative in front of the whole thing. Okay, now our next one, the 5th root of 232, so 5 second, this key here, and that's going to be 32. I got 2, but now we're back to odd, so it's only positive. Only the positive factor can equal the positive. Okay, now you're on your 5th roots, and 32's here. That's 2. Okay, now just to remind you, if you don't see a number there, it's a square root, so you're turning over back to the old list. And with square roots, I mean, you can do that too in the same key, but if it's a square root, you can just do what you've always done. Second x squared, 162, 12.73. And you can put the 2 and then hit that button. It'll do the same thing. It's back to even, so plus negative. Okay, then here we start dividing numbers into that. So 162 by 144 fails. 162 by 121 fails. 162 by 100 fails. 162 by 81. That succeeded. So these are square roots, and I just put 81 and 2. Square root of 81's 9. So it's 9 with a square root of 2. Don't forget the plus negative.